Hi, I'm Joel Woodward from Rohde and Schwarz. Making accurate and fast power integrity measurements continues to gain in importance as voltage values and tolerances get smaller. To address this issue, Rohde and Schwarz has introduced power integrity probes. Models come in both 2 GHz and 4 GHz bandwidths, and they can connect to a wide range of Rohde and Schwarz oscilloscopes. What's unique about these probes? One attribute is they have a low noise 1-to-1 attenuation ratio that's important when just a few millivolts of measurement accuracy is critical. They also offer plus minus 60 volts of offset when the built-in offset of the oscilloscope might not be sufficient for the measurement. Why high bandwidth? Design teams often struggle when high-frequency sources such as clock signals are on the power rail. The high bandwidth probes allow engineers to identify coupled signals on the power rail. Let's take a look at a specific example. Today I'm using an RTP oscilloscope. It's an 8 GHz model with 20 gigasample sample rate. Connected to channel 1 is a ZPR40 power rail probe. And I have the probe connected over a very high precision SMA cable that ships standard with the 4 GHz probe to a target system. I'm looking at a 1.5 volt signal from an FPGA power rail. If I look at the front of the oscilloscope, I can see that 1.5 volt signal. I really want to zoom in to look at additional signal detail. So let me change my vertical scaling. Here's what my power rail looks like. There's some behavior that I expect here as well as some unexpected behavior. In fact, I can see coupling onto my power rail. If I turn on an FFT, I can do a small coupled signal on it, and I can precisely look in the frequency domain of what that coupled signal looks like. One of the neat things about the Rohde and Schwarz FFT is that I can move the gated FFT to another area of my display, and then I can look at what the frequency content is of signals that are covered by that gate. In summary, Rohde and Schwarz has great tools for power integrity measurements, both specialized power rail probes with very low noise, as well as oscilloscopes like the higher bandwidth RTP. These tools allow engineers to make very precise and accurate, fast measurements on power rails, as well as the higher bandwidth allows them to see signals that might be coupled from higher frequency sources.